We are live. WeatherBrains, episode number 652. This is the pre-show for July 16th, 2018. Time of the show where we do three very important things. We share boring personal stories, humorous anecdotes, and we say occasionally outrageous things. Brian Peters, the man that looks like Colonel Sanders, has weaned out, Bill.
Yes, he has. Just because there's an election tomorrow. Come on.
You know, he says he has to work at the polls. So what time do you have to be down there? Like 3 a.m. or what? I mean,
I have to get up early to beat these rooskies at their meddling.
So anyway, he's out. Flash flooding. Flash
crazy?
flooding.
Out of the blue, didn't it?
Got all kind of images rolling in here.
I wish that storm would work its way down here, maybe in a weakened state.
Hey, tap on your mic, Bill. Sounds like you might be on your.
Yeah, no. I didn't have it in the right spot. Sorry, I'm just trying to multitask here. 12 tasks. I've been writing a script for you all day.
Oh boy.
WGM, world's greatest meteorologist. All right, let's see. That's 2. In case you're wondering what I'm doing, I'm separating season tickets over here so I can give them to Nancy in our office because she's going to the Barons game. Right, so now it says we're connected, so good. All right, now. All right, so you can hear me okay, and I can hear you okay.
Get the weirdest
frying bacon
video. This flooding video.
Well, at least not the pictures you get during the winter with guys in their Speedos sitting out by the grill in the middle of a 4-inch snowfall.
That's awesome. Those are the greatest shots. So I signed up for the NWA annual meeting.
Oh no! Today's like the end of the early bird. I'm glad you said that.
I signed up yesterday, and
so you made the early
click here, and so I paid. And of course, you know, I got burned on this AMS deal a couple of summers ago. It was last summer when we had the tropical system, and I couldn't go.
Right,
and they didn't give you a refund. So when the hurricane blows up, I'm counting on somebody to give me a refund here. Then I clicked on the click here for hotel accommodations.
Sorry,
I click here, and there's no rooms. So great. I'll be staying at the Dewdrop Inn in.
Well, everybody that's coming that has not gone out there and canceled, you know, your reservations for what you don't need, please do that because that frees up the room block. And you have to play these room blocks so tight because, you know, you can't undercommit or you can't overcommit and then get penalized, you know, $20,000-$30,000 for not meeting your block. It's an art and a science. I don't envy Janice for what she has to do. There are lots of good hotels nearby, though.
I'll be staying at the Roach Motel in West St. Louis.
There's a really good Hampton that's about 3 or 4 blocks away. It's not bad.
No, I don't see. I'm the lowest maintenance guy. I don't care. I have never cared about accommodations.
Well, there's probably a few thousand people that would let you room with them, I bet.
That's a show title.
Can't have a show title in the pre-show, though, I heard.
The QPF, the next rat is up to 5.88 in Jasper.
Oh my goodness! These are some efficient storms. There's no question.
Yeah, we are.
They know how to wring the maximum out of 2.2 inches of precipitable water. What was the final total last night at Calera? Because I mean, they were popping some amazing numbers.
Shelby County Airport had like 2.5 inches,
but they got 1.01 of that in 9 minutes.
Wow,
that's impressive.
Yeah, that's.
I guess I better invite the guest. I'm just sitting here jawing.
Yeah, 5.88. That's going to ruin somebody's night there.
But is there rain gauge like their temperature sensor though?
No, this is a NexRad estimate.
Oh, NexRad. Sorry.
Right. This is not observation.
You know what's funny? There's a guy in Tuscaloosa who kept, driving me crazy because he was in Tuscaloosa and there was no rain at the airport for days on end when, there was tons of rain downtown and wherever he was, it was raining all the time. But at the airport, there was no rain. And now today, Tuscaloosa has broken their record for most rain ever in any July or something like that.
Yeah, it's over 10 inches.
And it's like in the top, I don't know, Scott was telling me so many top 10 of all time months or something like that. But James, how did they get away in 1916 when Birmingham had 20 inches of rain in the month? How did Tuscaloosa not get at least, 12 inches of rain or so? That's from a dying tropical system. That's kind of weird to me.
Yeah, data integrity back in those days. I don't know. I don't know. Where's JB? Where's JB when you need him? He would know.
He would remember. He was there.
All
right, let's see.
I always get these hate messages from these flash flood warning when you said there was a 20% chance of rain, you moron.
Do you know how to read the blog?
No, they don't read any of our products. They open up these crap apps, and that's what they get. And
read the blog.
Well, they're not going to do that. They just.
I'm getting me a T-shirt that says that. Read the blog. Tonight when my weather radio went off, I turned and looked, and that warning was already on the blog. I was very proud of that, James.
That's cool. No, I'm here.
There we go.
I'm multitasking.
Watching the home run derby tonight?
I had it on, but then it's flash flood that now we're 6.09. Wow.
Oh my goodness. Got to build an arc.
This is not good.
Any of your workout buddies in the home run derby? 2, 3, 4, 5.
No, I've got one playing in the All-Star game tomorrow night, but not in the Doiby. This thing just does not want to go away.
You got a big cell merger right there that happened right over Jasper.
Yeah, this is just not good.
It's getting smaller now, but it's getting smaller over Jasper.
And it's over the same place.
Yeah. What's the?
I see Rick Smith.
Yeah, when you see gray on the rainfall indicator, that's not good.
Yeah, I'm looking at. I would believe 6.09. I would totally believe that.
Yeah. Yeah, you're right. That's crazy. Ooh, wee.
Okay.
Good evening.
All
right.
Yeah, we're at 28 after here. I'm all distracted by this weather. I'm distracted by weather. So I was on this other show last week, Storm Freaks.
Yeah.
Storm Freaks. Those guys were funny. They're good. They were my kind of people. They were. They played their sound effects. I played my sound effects. I took them right down the tubes. So if you want to hear WeatherBrains on another weather show, go to Storm Freaks. I don't know what their website is. But those guys were fun. That was good. We had a good time.
That's good.
Yeah, 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09. 6.09.
what's the call sign for the Jasper Airport? Uh-oh, I shouldn't have touched that. Let's see. Aubrey's out for tonight.
Now, where is everybody? It's like just me and you. I see Rick Smith's picture. I don't hear his audio.
Hey, I'm here. Can you hear me?
Yeah.
I'm going to be audio only tonight, unfortunately.
Okay.
Uh-oh. The guest says he's having trouble too. He did great on the test hangout.
It always works this way.
I just get instructions and not straight to live video. Huh. James, I'll drop a Gmail address.
Let me welcome our television viewers. It is Monday night. We know we got some active weather. We'll keep you up to date here. Just hang on. But we are about to start WeatherBrains. And longtime viewers here know we do this every Monday night at 8:30 Central. That's when we are joined, and we are glad that you are with us. And as soon as we get our guest on here, then we're going to get this thing rocking and rolling.
If not, we can just now cast the flash flood warning for an hour.
Here he comes.
All right.
There we go. You scared me there, David.
All right. Hey, David, give us a quick audio check. You muted yourself there real quick.
All right. Can you hear me?
There we go.
What's that thing behind you? Is that a psychiatric thing where you have to look at it and tell you what we think it is? What do you see?
Well, what do you think it is?
Oh, there you go. He turned that around on you.
No. It looks like trying to look at a radar through an old analog UHF TV channel 100 miles away in 1963.
Okay.
Yeah, I'm the only guy to get that.
As far as I understand it, when I'm here at NRL, and when they built this building, they asked if scientists could create art out of various projects they do, and this is from some simulation that somebody put together. But that's all I know.
Some great meaning there. We don't know what it is.
Yeah.
Right, let's get this thing started. We are here, and we are going to roll this sucker. And if y'all lose me if you see me black out during the show, I got to step over to the studio for just a second due to some flooding issues here in my local market. So we're recording, and here we go in 5, 4, 3, 2, 1. Hey, this is WeatherBrains episode number 652. This is the weekly show that's all about weather. This is for July 16th, 2018, and the good old summertime, the dog days of summer. And often the dog days of summer tends to mean a lot of our people are away on vacation. They are playing. But the true weather weenies are here tonight, including Rick Smith. And for those watching, Rick doesn't even have a camera. But we know most of you listen. So, Rick, if I didn't say that, they wouldn't even know.
That's right. So, no, good to be here. Hate we're missing some people, but it'll be a good show. It is hot. It is the, I don't know if it's technically the dog days of summer yet, but it's close enough. We're going to be several days in a row over 100 degrees here by the end of the week, it looks like. So, blah.
Ooh, now, Rick, you're not in the nude, are you? And notice with no camera here. Is there a reason for this? Or is there anything we don't need to be seeing, or what?
I can assure you that's not the case. No.
Okay. Yeah. It just happens. It just happens. So, yeah, we'll do a weather roundup.
Technical difficulties.
I totally understand. For those that don't know, Rick is the Warning Coordination Meteorologist at the National Weather Service in Norman, Oklahoma. And Bill Murray is the grand poopah of the National Weather Association, getting set for his big party next month.
Oh boy, we're deep in it, James, and you get to taste a little bit of it tomorrow morning when we have a meeting, because I've been working for 9 hours on a script for you today, and with I haven't even told you yet, but a major celebrity may be your sidekick.
So what am I supposed to be doing here? Like, I got some note that said I'm speaking at noon. Well, is that still right?
You don't have to do that. I actually removed you from that. Because you're going to have enough to do as it is. You've got 3 stage shows on the center stage at the St. Louis Science Center, and you'll be basically working with 150, 200 kids and families talking about flash flooding using the ALI Skywarn Young Meteorologist program, using that program's module. And your buddy Jim Stefkovich will be running the computer, so it'll have a real good hometown feel to it. And a celebrity who shall be named later will be your sidekick.
Wow. Okay, I'm
a
intrigued.
big celebrity, a national celebrity. And
Is it
you are
Rick
at
Smith?
such a level.
Is
No,
it
it's
Rick
not
Smith? No.
It's even bigger than Rick. I didn't think about Rick. That was a good idea. But it's even bigger than Rick. It's hard to get bigger than Rick. But, you know, and this is somebody from your past that you know well.
Okay, well, I'm intrigued. So Rick Smith, are you coming to the NWA in St. Louis next month?
Sadly, I am not. I hate to miss it. I had such a great time last year at the in Anaheim. Hate to miss this one, but we'll be following all the activities on Twitter, I guess.
And today, Scott Martin ordered 75 shirts. We have 68 volunteers, James, for the event.
Wow. Hope some people show up. Man, that's a lot of people.
Well,
of course,
we
it's
expect there'll be 7,000 people show up. We're producing
What?
6,000. We're producing 6,000 passports, and the passport is just spectacular. 28 pages of weather safety education information, and the passport is, you know, basically the game piece for the event. It carries people around to the 50 or so exhibitors that'll be there. 3 TV stations doing, will be there that day. It's going to be an amazing event. So, and you're one of the headliners.
Oh boy! All right. Well, let's bring in our guest here before he hangs up on us. He's heard enough boring stories about St. Louis.
Well, that's all right. He'll make it. Tonight's guest weather.
Maybe he'll be in St. Louis. Maybe he'll be there.
I haven't even asked, and that'll be my ask in just a minute. He's a meteorologist at the Naval Research Laboratory. Dr. David Peterson, welcome to WeatherBrains.
Hi, it's great to be here. Thanks for having me.
Now, when I was a senior in high school, actually a junior in high school, I did a science project on hurricanes. And the nice people at the Naval Research Laboratory awarded me with an award at the International Science and Engineering Fair that was a beautiful leather briefcase. And I carried that briefcase for probably 30 years. And I treasured that thing forever. It had embossed in gold on the briefcase. I thought that was the coolest thing. And so I want to go ahead and just thank you for that for that award. Some 57 years later, or however long it's been since 1979. James, how long has that been? 1979, 21, 39 years. That's pretty good.
Yep.
So
not bad.
Where were you, James Spann, in 1979? In April 1979.
April of 79. I was working at WSFA TV, Channel 12 in Montgomery, Alabama.
You have to tell that story about when you and the chief went out to dinner that night. Can you tell that story, or is it?
What? Oh boy, this is a disaster. Why would I even share this? But here's the quick version. So, and understand, I was a kid. I was 22 years old, 22, and very immature. Not that I'm much more mature now, but
nothing's changed.
And I worked weekends, and the weekend anchor team decided to go get some food after the 6 o'clock news on a Saturday night. So the news guy wanted to go to a restaurant called Quincy's. And I bet you I'm the only guy on the show that's ever heard of a restaurant called Quincy's. It was a chain steak restaurant. And this was on the Southern Bypass in Montgomery, Alabama. And the guy driving we took a news car. The news guy was driving, and he parked right by the front door in a handicap place. Now, and understand, in to his defense, in 1979, this was a new concept, brand new. But I said, even in my immature state, I said, Norman, you can't park here. I think this is for handicapped people. And he said, what do you mean? I mean, we're in a hurry. We got to eat and go back to work. We're parking here. So being the 22-year-old that I was, I said to the group, well, if we are here, I guess that we should be handicapped. And we got out of there. And I'm embarrassed. Why do you make me tell this story? This is horrifying. I mean, it's even worse.
I forgot it had a bad side. I thought that was where it ended right there.
No.
This is the Paul Harvey rest of the story.
We got out acting as though we were handicapped. And it was horrible, just horrible. And a lady in the restaurant saw it, and she wrote a letter to the editor of the Montgomery Advertiser, the Daily. And you talk about how horrible it was when these three well-dressed gentlemen got out doing that. And then she said she was even more shocked and disgusted when she saw the same three men on WSFA TV news that night. So that could have been a career
in the business.
that could have been a career ender. What's so odd? Well, number one, most people in town thought it was the weeknight crew, Bob Howell and Dan Atkinson and Phil Snow. And the other thing, the only guy that got in trouble was Norman, the guy that drove the car. They never called me in. So, but I'm confessing my sin. I'm embarrassed. It was horrible. And trust me, I've never done that again. So that ended any chance of me ever acting up in that way again. So that's my horrifying story. Thank you for the embarrassment.
Sorry about that. I didn't realize there was a rest of the story. I thought it ended with
No.
with you parked in the handicap zone. I didn't realize there was more to the story.
Yeah, I'd say that's the low point of my life right there. So,
well, I mean, it's good you rebounded from it. So,
yes.
But anyway, sorry about that, David. So David, before I go any further, what are you doing August 25th on that Saturday? We may need you in St. Louis.
Ooh, I think I'll be on my way. I'll be on my way back from Houston at that point, actually.
Oh, good. It's an easy flight. Stop over in St. Louis and represent the NRL at the Weather Ready Fest. That would be a lot of fun. But anyway, David, talk to us about your background and how you got to your current job and what you do for a living day to day.
Okay, well, I am currently a meteorologist at the Naval Research Laboratory in Monterey, California, where it is considerably cooler than what you guys are experiencing. I think we only had a high today in the 60s. So when you're on the coast here in the summer, it really keeps things cool. But anyway, I started out at Valparaiso University, did my undergrad there. And I grew up as your typical weather nerd in Northwest Indiana. So interested in severe weather and lake effect snow and all of those things. Went through schooling at Valpo, where you get to do a lot of storm chasing. It's one of the things they offer at that program. It's really great faculty. They made learning really fun and encouraged me to go to grad school. And so I applied and ended up at the University of Nebraska. And working there, I just got involved with satellite remote sensing technology and Earth observing techniques. I did an internship at NASA Goddard as part of that program. And that's what got me into the wildfire side of things. So, one way to monitor wildfires is from space. That's the only way you get a global picture. And so from that came my grad school, looking at wildfires from space, basically different ways to characterize them. And that all feeds into the work I do here at the Naval Research Lab. So this lab is very broad. There's a lot going on here because the Navy is global. They're everywhere. So we do work spanning everything from tropical cyclones to more applied tactical support type of things. But the group I work in specifically is focused on what are called aerosol particles. So that's dust, smoke, pollution, anything in the air that can scatter radiation, that sort of thing. But we also do, again, a lot of satellite remote sensing type of work. And so it's a very multidisciplinary group. And again, my focus through the years was wildfires, but these days I'm doing quite a bit of different things here.
So that's interesting to me, and I'll come back to a second question in a minute, but talk about how important satellites are to the military. And I guess weather satellites in particular, not to mention GPS and other type applications that are out there. But one of our readers just asked this question in the last week, for someone to talk about that importance. So talk about that to us for a minute.
Satellites are becoming more and more important. They're one of the most important things, from everything from just the assimilation of data into weather models relies on satellite data, to your basic tracking of thunderstorm development and hurricane development. It's also relevant for, say, if you're tracking a large dust plume moving across the Atlantic Ocean from the Sahara, or in my case, large smoke plumes from wildfires. The only way to do that in a broad, big sense is you need a satellite sensor in space. And so as the satellite technology improves more and more and more, we have better data. it results in better predictions and better monitoring capabilities.
Yeah, there was this interesting article in Wired, and I told Elle before we went to bed last night I shouldn't have read this article. There are very few articles that keep me up at night, but it was about, you know, the threat to our satellite constellations, you know, from the global superpowers now beginning to develop military technologies that can take a satellite out. And because of our dependence on satellites in so many ways, not only the military, but the economy and, you know, and other things too, it's very frightening that, you know, blowing up a satellite could produce 100,000 pieces of space junk that, you know, could take out other things. Or if we got into a full-blown war with someone, we're pretty vulnerable. So I shouldn't have read that article before I went to bed last night, David. So comment on that.
Well, you know, that's a bit out of my area. I use the data, but I can't really comment on you know, what could happen in those situations. But yeah, there's no doubting the fact that satellite data is important, and we rely on it a lot. And so, you know, if it wasn't there, we would have obviously some potential issues, but I know there are groups working on addressing that potential. But again, that's a bit out of my area.
Now you mentioned your younger days in Northwest Indiana and a couple of our favorite subjects, lake effect snow and severe weather. Talk about, you know, the events that drove you to become interested in weather, because everyone experiences these things, but not everyone becomes a meteorologist.
Well, that's true. So like a lot of typical kids in the Midwest, I was always looking for snow days. And I grew up on the south shore of Lake Michigan. So we have a snow belt there for lake effect snow, except I was always getting upset because the snow bands were always missing us. And I always wanted to know, well, why are they just going east and everybody else is getting feet of snow and we still have to go to school? And so that's one reason I got interested in the weather, is trying to explain that, you know, that, yeah, you know, the prevailing winds are not always going to bring it over our house. But then also there were, over the course of growing up, multiple severe weather events in the Chicago area. One that really stands out is the Plainfield tornado in the early 90s. And I was just old enough then to start remembering weather. And that actually motivated a lot of people my age from that region to get interested in the weather. And besides that, it's your typical, you know, crazy type Midwest weather. So blizzards, we had a lot of floods. It's just, from a place to grow up, the Chicago, Northwest Indiana area is a pretty good place for weather.
Well, I know forecasting lake effect snow is not simple, but talk to us about the processes involved. It's kind of a foreign concept to us. On a really, really cold day down here in Alabama, we'll occasionally get some minor lake effect, you know, snowflakes off of the major lakes in the Tennessee Valley, that sort of stuff. But it's a big deal for places around the Great Lakes.
Oh, yeah. You know, I don't do research on that subject, but the basics, when you have a lake as long as Lake Michigan, which is 300 plus miles, if you can get the wind to come down that full fetch of the lake, and, you know, you have decently warm lake water and really cold air temperatures, that's really all it takes. You can actually get a land breeze sort of set up where at that time, the air over the land is colder than the water. So you get this feedback of two land breezes coming from the narrow or the long sides of Lake Michigan, pushing all that snow into one big band over the center of the lake. And those are the ones that really got me interested in the younger days from a winter perspective. That was before I even got interested into wildfires, which is what I do now.
Yeah, I never thought about that land breeze convergence thing. I mean, there's probably no better place than Northwest Indiana and the extreme part of northeastern Illinois to get that full fetch, is there?
Yeah, well, you can kind of think of it as a reverse effect of what happens in Florida in the summer. Mm-hmm. So in the summer, you get the two sea breezes converging and thunderstorm development. So over Lake Michigan in the winter, you can get two land breezes converging over the center of the lake. And that produces the snow band, or at least focuses the snow band.
So how good at forecasting were you as a young person when you were trying to collect those snow days?
Well, for big snow, it's obviously easier than lake effect. But I remember getting better and better at it, and then I was a little less frustrated when we didn't have snow days. But then I went to school at Valparaiso University, which is one county over, and that's all it takes to put you in the heavy snow. So for those 4 years, I had a lot more snow.
So you probably came after Dr. John Knox was at Valpo, right?
Correct. I was.
And Ginger Z, was she there when you were there?
Ginger Z was a few years before my time. I don't remember exactly when, but we didn't overlap.
And I'm excited. She's going to be the MC at the Weather Ready Fest in St. Louis. I'm really excited about that. So, Naval Research Laboratory, talk more about its history and its role. I'm bearing the lead here because the reason I had you on the show, we haven't even touched on yet. But
okay.
So talk about the NRL for a minute.
Okay, so NRL is a lab with the primary mission of supporting the U.S. Navy. It's a pretty big lab. A lot of it is located in the Washington, D.C. area. Here in Monterey, we're just one division. We're the Marine Meteorology Division. But our mission here is specifically anything in the atmosphere that will impact naval operations. So here we run a global weather model called NavGem, similar to the GFS and the EC. We also have a mesoscale model called COAMPS, which can be run at a variety of different resolutions. We have a data assimilation system to support those models. And then we also have a lot of applied science. We have a long history here with satellite remote sensing. A number of the viewers may be familiar with the tropical page that we have that follows tropical cyclones. It's been around a long time. But there's a lot of other satellite technology that we've produced. And then we also run, in my group, a global aerosol model. So, you know, the Navy's a global operation, so we're predicting dust, smoke, pollution, anything that would impact visibility or energy propagation worldwide. And so especially the big events, so major dust plumes, big smoke plumes, or areas where you have a lot of haze and low visibility from pollution. Those are the types of things that we're focused on.
Yeah, that's some amazing stuff there for sure. Now, the article that caught my eye was an article talking about your research into wildfires being actually as efficient at producing particulates into the atmosphere as volcanoes. And since we have sort of had fewer volcanoes or fewer major volcanoes since, you know, I guess my great volcano is Pinatubo. Talk about this research, how it came into being and what you found.
Yeah, well, why don't we just start with the volcano subject? Because a lot of people know the Pinatubo eruption in '91. That was a big volcanic eruption that had, you know, climate-altering consequences, at least for a couple of years. Enough material, and so in these cases, these volcanoes are injecting smoke into the stratosphere, and that's the impetus for creating changes in temperature and that sort of thing. But the issue is that those big eruptions are pretty rare. We haven't had one since '91. Your more common volcanic eruptions, those, you know, they happen every so often, but they're still pretty rare. But the subject of our research is wildfire-driven thunderstorms. So these are just like any big thunderstorm cloud, except in this case, the updraft is fueled directly by the heating from the fire. So in a sense, it's a lot like a volcanic plume. It is taking smoke in the updraft and feeding this, what becomes a very polluted cloud. And it also has potential to inject smoke at similar altitudes as a volcano. So that's jet aircraft cruising altitude and above. So the upper troposphere, lower stratosphere. And so I can walk you through what happened this past summer, if you'd like, on how this all really came to be.
Please.
Okay, so the summer of 2017 was the most active wildfire season on record in British Columbia, Canada. Many places really in Western North America. So over the course of the summer, large wildfires burned for many weeks. And as we arrived on the evening of August 12th, 2017, there were many large ongoing wildfires in British Columbia. And what so happens that the meteorology that night was also very favorable for convective development, thunderstorms. And what happened is that in 5 locations along these active large wildfire fronts, there were 4 or 5 what we call pyrocumulonimbus. So that's the technical term for a fire-triggered thunderstorm. Community calls them pyro-CB for short. So, regular thunderstorm is a CB. These are pyro-CB. So anyway, you have 5 of these big events within about 3 or 4 hours on one evening, mostly in British Columbia. And 4 of them were monsters. I mean, we're talking sizes comparable to a supercell thunderstorm, massive anvils, and all of them had overshooting tops from the troposphere into the stratosphere. So you can imagine what you have here are like 4 giant chimneys. So again, the heat from the fire is driving these updrafts, so most of the smoke is going into these clouds, and that's all being lofted very rapidly to high altitudes. And what we ended up with a few days later was a large smoke plume in the stratosphere, spreading out across North America. Over the course of about 3 or 4 weeks, it actually encircled the entire northern hemisphere. It was observed over Europe, Asia, and then back again across the Pacific. And the signal of that smoke in the stratosphere was there for about 3 to 4 months. So really, until now, the only time you've really seen something of that magnitude is with a volcano. That's exactly what you see when a volcano erupts. You see that same signal persisting in the stratosphere for multiple months. And so that's where the comparison between volcanoes and pyro-CB comes. Because in this case, all of that material was from wildfires.
And so what sort of volume are we talking about from these monster cells that night, and how would they compare to a typical moderate volcano?
So we actually compared to a volcanic eruption in the Aleutian Islands of Alaska in 2008. It's called Mount Kazatochi. So, over the past few decades, we've had a rapid proliferation in available satellite data, and that particular event was well studied. It was a similar location, similar time of year, and injected volcanic material to the same altitude as these pyro-CB thunderstorms. And what we find is that in terms of order of magnitude, we're almost exactly the same between what the volcano produced into the stratosphere and what the wildfire thunderstorms did, at least in the initial phase. Again, since it's smoke versus volcano, the chemical composition is a little different. So what happens after the fact is not necessarily the same. But in terms of the initial mass injected into the stratosphere, we're very close.
And how would it compare to a Pinatubo type eruption? Anywhere close?
So no, Pinatubo is in a league of its own. That's a couple orders of magnitude more in terms of the impact. But in terms of your more typical moderate volcanic eruptions, this wildfire event is very similar. That eruption in 2008 from Mount Kazatochi is actually on the upper end of what you'd consider a moderate volcano. And so for these wildfire thunderstorms to be even close is quite amazing.
So any climate altering effects from these thunderstorms that you could determine, or is it just too small of an ejection?
Well, we know that there was, like I said, a smoke plume encircling the entire northern hemisphere. So there's obviously some impact there. But the big science question that we're trying to understand is simply that. What is the potential climate impact from these events? We now know that the total material is similar to a volcanic eruption. Then the next question is, okay, well, if we look at these events over the course of, say, a few years, over an entire hemispheric scale, because this is just one big event. We've done a lot of work looking at the meteorology behind these events, which suggests that pyro-CB really aren't that uncommon. We see them every year across Western North America, Canada, Asia, and Australia. So if you have a big one like we had in 2017, you can have a volcanic type impact in the stratosphere. But you can imagine if you have several of these over, say, a fire season, we've already had a few this year across, say, the whole northern hemisphere, that cumulative impact from more typical pyro-CB events may also be significant.
And so you mentioned that the atmospheric conditions that night in British Columbia were more conducive to thunderstorm development. Do these storms bring their own instability with them, basically, or their own updraft power, or do they need a special set of conditions to really happen?
So they definitely need their own set of conditions. So if you imagine the western U.S. during the summer, you often have monsoonal moisture coming in the mid-levels of the atmosphere, and you get thunderstorm development over the high terrain. So when it comes to these pyro-CB, it's a similar type environment. There's usually a moisture source somewhere in the mid-levels, so you have your typical inverted V type sounding profile. But you have to also maintain a large and hot fire. So the low-level environment is extremely dry, it's unstable, and there's very little wind shear because you have to maintain a vertical smoke column. So you can kind of imagine it's the opposite of the environment you'd have in Alabama. So the low-level environment is very dry and unstable, and then it allows you to maintain a very big vertical smoke column. And once that gets into the middle part of the atmosphere, you encounter the moisture source, and that's where the development of the thunderstorm occurs. So it's not really the most exciting thunderstorm environment, right? I mean, this is the opposite of what a supercell or storm chasing type weather would be. But it's the only environment that allows you to maintain a hot fire at the same time as deep convection. And oftentimes we see that exceed the tropopause. But again, the heating from the fire does allow you to produce some additional instability in the low levels. So sometimes if the environment's not quite right for thunderstorm development, it's just marginal, that additional heating from the fire will allow that thunderstorm to go when it otherwise wouldn't. So you could break a capping inversion that way, or you can have a fire develop at a lower, or a pyro-CB develop at a lower elevation than a traditional thunderstorm would, just because of the additional heating. So it's kind of a unique environment. It's really interesting that way.
So the pyro-CBs don't like a lot of vertical shear, or are okay with it? What's the situation there?
Yeah, so pyro-CBs don't like a lot of vertical shear in the low levels. If you have a lot of shear, it'll cause that smoke column to spread out or lean over, and you need to get that momentum, that push up into the middle and upper atmosphere. So once you actually develop the cloud and say 400 or 500 millibars, that area, it's okay to have some shear there once the thunderstorm is ongoing. But in the low levels, the less shear, the better.
And so they don't rain themselves out, even though they're pretty vertically stacked, because the atmosphere is so dry?
So, well, oftentimes they don't produce any precipitation at all. So, like I said, this is a giant chimney bringing in smoke from a wildfire. So these are some of the dirtiest storm clouds you'll ever see. Just imagine a giant thunderstorm CB cloud in the distance. In this case, fill it with smoke so it turns brown, dirty looking. But that also causes a change in the particles in the cloud. You end up with a lot of tiny ice particles because it's additional condensation material. So that's not very efficient for generating precipitation. So, you don't, oftentimes there's very little reports of what comes out of these, but it might be just some small ice. Otherwise, you're not talking about any major precipitation. But they do generate lightning strikes, just like any other thunderstorm. So there have been instances where a fire-generated thunderstorm triggers another fire just from a lightning strike.
And what about fire whirls? We see some dramatic video from time to time of those, and those are really frightening.
So those are, but oftentimes those are generated by just differential heating at the surface between the fire and the surrounding land. It's not a tornado in the traditional sense where you have wind shear, supercell driven type of event. So those are usually pretty tiny. You can have those with or without the presence of a pyro-CB.
So Rick Smith in Oklahoma, you get some pretty destructive wildfires. Do y'all end up with some of these pyro-CBs in your neighborhood?
Yeah, we do. We had a pretty active wildfire season in the Texas Panhandle, Southwest Kansas, Northwest Oklahoma this past spring, and we did see some of that. And in fact, one day a pretty impressive thunderstorm developed from this this pyrocumulus and pyro-CB activity. So yeah, Probably don't see it as often as they do out in the west and the southwest, but it's not that uncommon here, and it's talk about fascinating and getting all the convection geeks and the storm geeks excited just seeing that happen, just because that fire is there and the heat from that and the energy is pretty amazing.
Did you see these overshooting tops on the GO satellite?
Yeah, we did. I think that we did, and we were calculating the height of the storm, and I can't remember off the top of my head, but it was a legit thunderstorm with an overshooting top and signature on radar and everything. So it's pretty amazing. I haven't seen that happen too often here semi-locally, but it does happen.
So David, do these pyro-CBs produce the same sort of effects that affect aircraft? Because obviously ash from a volcano is a really serious problem for jet engines. Do pilots have to fear them for the same reason, or just because they're just wouldn't be good flying through one of these?
So smoke from wildfires doesn't have quite the same impact on a plane. Planes can fly through the smoke pretty well. But it is a visibility concern in some respects. It's high altitude, so any sort of sensor technology that's trying to penetrate that layer would have an issue. But as far as a plane, it should be able to go through pretty easily.
And no real ashfall, just the effects of the smoke and the aerosols that it produces, I guess.
Yeah, but one thing we don't really know is we can make a lot of educated guesses on what the composition of that plume is at the top, but nobody's actually measured it. So, you take a volcano, we know it's mainly sulfur-based compounds, and so you get a lot of ash at the start of a volcanic eruption, and then you also produce a lot of sulfur dioxide gas, which over time converts into sulfate particles that reflect solar radiation back to space, and that's where you get the cooling effect from volcanic eruptions. But with a pyro-CB, we know it's more carbon-based, so there's a lot of carbon in smoke, and those particles tend to absorb solar radiation. So you have a layer that would be absorbing and warming itself in the stratosphere just because it absorbs rather than reflects. And we've seen cases with these big events where the smoke layer, even though it's injected just maybe a few kilometers from above the tropopause, it'll continue rising because it's continuously absorbing and heating from the solar radiation. So this particular smoke plume was injected at, say, 13 to 15 kilometers in altitude. But a few weeks later, it was observed at about 20. And so there's ongoing research to fully understand that, but that's where there's a fundamental difference between pyro-CB and volcanic plumes.
So David, why is stratospheric warming and cooling important to us as meteorologists on the ground?
Well, understanding that it's a big radiative balance question. So, in order to understand the climate, you have to understand the radiative balance, which is driven by clouds and aerosol particles and a whole host of things. And there's been a lot of study on volcanic plumes, and we know that their effect on radiative balance is to cool. But we have no studies right now on the effects of pyro-CB plumes and how that could potentially impact temperature and circulation and those sort of things. So we're hoping that with this, having looked at this one event in detail and quantified how much material made it in the stratosphere, it'll serve as a starting point for the modeling community to do those sorts of studies.
Now, is that sort of related to what you're working on there at NRL with the radiative effect of thin cirrus campaign? Is that sort of related in some way to contrails and high cirrus and things like that, or what?
So yeah, we do have a study on cirrus clouds. In some ways it's similar, looking at the radiative impact. But you can imagine cirrus clouds are pretty common, but everybody looks at them and they're really nice, and you sometimes get the halos, but they're really not all that affecting daily life, right? I mean, they're up there pretty high. They're ice. They're mostly ice, and they're very thin. The issue, though, is that since we've gotten better and better observations from space, we know that a large part of the planet is covered by cirrus clouds at any given time. And some of them are pretty thin, and they're thin enough to where your regular satellites can't really identify them. They see the ground through them. And so when this all comes back to what I mentioned about assimilation of data into models, if you're missing a lot of thin cirrus, then you have some contaminated data going into the models that are filled by these thin cirrus clouds that aren't part of a typical cloud masking technique or way to remove that. So the project we're involved with is actually putting a high altitude plane, the WB-57, through NASA to get measurements of radiative balance above and below the clouds and to actually see particle size. And that way we can quantify the radiative impact of cirrus in sort of a modeling sense, but we can also, using the new GOES technology, the new satellite, geostationary satellites have sensors that are much better at detecting thin cirrus. And so from there, we hope to develop an improved cirrus detection to account for more of these thin clouds that are making it through into the weather models right now.
Because that would indicate the presence of high-level moisture, I suppose.
Well, that and it also just contaminates the values that come out of the satellite sensors. So each individual pixel from a satellite, if it has cloud in it, and you assume that it doesn't, that's a problem right there.
So I at the risk of triggering the chemtrails sound effect here, if the host is still listening.
Wait a minute.
Chemtrails.
You know, I've heard some interesting research, you know, from time to time about, you know, 9/11 when we grounded all the airplanes and you know, when we had no contrails, that there may have been some temperature effect. Comment on that, David.
Well, that's a bit out of my area there, but the one thing I can say from that is airplanes, just like wildfire smoke or just like anything like that, is producing particles in the upper atmosphere that can act as condensation. So from that standpoint, it could have an impact on global cloud cover, but I haven't actually done those studies myself.
Interesting.
Chemtrails.
But we are, yeah, we're not hiding any chemtrail.
You could only live over here on our side, David. You wouldn't believe the chemtrail loons that, and they're brutal. They're not nice people. They are convinced the government's controlling the weather with a team of pilots that spray us on a regular basis, controlling our thoughts, actions, and behaviors. So,
well, I can assure you we're not trying to do that here.
Okay, that's another branch you got.
Chemtrails.
Yeah, the deep state. Oh my goodness!
Don't get me started on the chemtrail loons. If they were at least nice, but they're just mean. They're horribly mean people. But I have a little picture of a patch, a chemtrail pilot patch. I give the distinct haters and trolls that come on the Facebook. So there you go. We'll send a chemtrail patch out to David.
Yeah,
I could use one. That would be fun.
Yeah, I need one. I'm going to get one right here. Yeah.
So, David, we're talking about wildfires, and of course, 2017 was a really bad season. Do you see evidence in your research that the wildfire seasons are getting worse, or are they about the same?
Well, there are studies out there showing that wildfire activity has increased over Western North America. But then there are studies that have come out recently showing that wildfire activity globally is actually going down slightly. And that's because there's a lot of agriculture-driven burning in the equatorial regions. And as more and more regulations are put in for that, it tends to decrease. But, and that's globally. But if you consider now the piracy bee, the fire thunderstorms, what matters for that is that you have a certain meteorology in place. And so that's somewhat independent of what the wildfire activity is doing. You need to have an active wildfire at the same time you have the right meteorology, but it doesn't necessarily mean that if you have increasing wildfire activity, you'll have increasing piracy bee, because the two are similar, but not necessarily related. And, you know, piracy bee are just one phenomenon of the whole fire weather interaction picture. So, you know, you've got situations of extreme fire spread too, where a wildfire is growing, you know, an immense amount of area being burned over, say, a few hours. But that also doesn't necessarily mean you're going to have a piracy bee. So it all depends on the weather, really, just like everything else.
So have you spent any time as an IMET or forecasting for any wildfires ever before?
So I've never been an IMET for wildfires. I've been on the research side the whole time, but I've done a lot of forecasting for field campaigns that are targeted at just really specific objectives. So the Cirrus project that we were just talking about, I'm a forecaster for that. And I've also forecasted for a few additional campaigns that are related to wildfires. But that's kind of like storm chasing with a plane. So you have aircraft that are trying to sample certain things, and you need to put them in a specific place. So the plane's moving, the smoke is moving, the fire's changing, and you all want that all has to happen at the right time.
And so you certainly don't want any chaser convergence in that situation.
No, but we don't. As long as the commercial flights are out of the way, I think we're usually okay.
That's good. And one other interesting package or program that I saw that you're part of is the NASA-sponsored Korea U.S. Air Quality Campaign. What is that all about?
So that was a project it's sponsored by NASA, and we were part of that. It was joint Korea and U.S. It was primarily an air quality focused campaign in Eastern Asia. So Korea sits at a kind of a crossroads in East Asia, where they're impacted by their own pollution that they produce, pollution that comes from mainland Asia. And then you've got dust coming in from the deserts in China and Mongolia, and you have potential for smoke coming down from fires in Siberia. So when it comes to looking at what's affecting air quality, that's a pretty good place to be located. And from a Navy standpoint, all of the different constituents that we try to forecast are present in that area. And at the time of the campaign in 2016, there were several new satellite sensors that had just come online. One of them was the Himawari satellite that the Japanese launched, which is really the first version of the current GOES satellites. Mm-hmm. So it gave us a chance to get a jump start on using those data by being over there. And I'll tell you one of the most interesting things about being in Korea, especially this was in late spring, is you get some really, really bad haze in the low levels. It's very, very unhealthy. Certain weather conditions come together. Usually behind a frontal passage, you'll have a little bit of subsidence, and you bring in a lot of pollution from, say, regions in China, mixing with the pollution that's already there over Korea, and it's moist, so those particles tend to swell up. And that alone creates some haze, but there's also chemical reactions that occur that produces additional particles and just feeds back on itself. And you get this really thick layer that's really hard to see through near the ground. And that's something that the Navy is trying to forecast, and then you have a number of people involved in the campaign that are looking at how that affects human health as well. Mm-hmm. So I was also a forecaster for that campaign, and that was a lot of fun forecasting in a different part of the world, a different type of meteorology, and working with the chemistry community over there.
Let me ask a question about
did he eat any kimchi when he was in Korea? So James Spann is a big fan of kimchi.
Oh, we ate kimchi almost every night.
There you go.
We did Korean barbecue at least 2 or 3 times a week. It's and kimchi comes with it. That's great food.
I'll bring some to our breakfast in the morning, James.
What is this, barbecue goat? What is it? I forget. I've tried to put this out of my mind. Squirrel, the raccoon. What is it?
No, you and I need to go have Korean barbecue sometime, James. I'll bring kimchi for you for breakfast tomorrow. I've got a big bottle upstairs in the refrigerator. When I opened it up,
liquid. I thought it was barbecue.
Bubbling. No, kimchi is a fermented vegetable like a radish or cabbage or something like that. And they ferment it with some spices, and it's really, really quite tasty. You'll love it.
So David, the African dust that we deal with seasonally, is there any skill at calculating that factor into a seasonal hurricane outlook? The ENSO phase obviously is a big part of it, but can you predict a dust plume in advance?
So yeah, we run a model that does precisely that. It's based on detailed dust sources worldwide. So the Sahara is obviously a big dust source. And we can forecast that plume moving across the Atlantic Ocean. We have scientists here that are looking at that in depth, engaged with people in Puerto Rico and Florida and all those areas that are impacted by that every year. But in terms of the impact with tropical features like hurricanes, that's an ongoing area of research where there's lots of different opinions. And we're not as engaged in that. Our primary mission is just to forecast where that dust plume is going to end up. And we do that when it comes to big plumes like that, we do that pretty well these days. It's the smaller dust plumes driven by convective outflow that are a little more challenging.
Yeah. So we're practitioners here. What's the rest of the hurricane season going to be like? Go.
Oh boy. Yeah, I'm not a tropical guy. Yeah, tropical. We have a lot of scientists here at NRL that would be happy to answer that, but I'm not the guy for that.
Oh, come on. We're just talking between us here. I mean, nobody will tell on you.
Well, from what I hear, the sea surface temperatures out there in the western, or I guess, yeah, the eastern Atlantic are below average this year. So I wouldn't be expecting anything big out there, but beyond that, I can't really give any more guidance.
Yes, he's not going to talk to us, Billy. He is, from what I hear. See, he knows, but he won't tell us. No, most everybody, they backed off with El Nino an El Nino phase beginning, the cooler SSTs, a lot of dry air, but you never know. All it takes is how many?
Just one,
and it becomes a big season. So you keep hearing, for example, on the tweeter here a few minutes ago, got an image of a sunset over Central Texas, and the caption, the Sahara Desert over Central Texas. How much of that dust has made it to Texas? Is that a legitimate point he's making?
So that actually happens pretty frequently in the, say, spring to early summer timeframe. It'll ride along kind of the way the trade winds do, following east to west progression. And you'll get these really dry layers filled with dust that are usually above the surface a little bit. But it's definitely made it to Puerto Rico multiple times. Florida is impacted, and occasionally it makes it as far as Texas. So that's potentially legitimate there.
Yeah, I think it is. I mean, there's a lot of folks have commented on that. Weather Service in Houston, they've mentioned that. And I will say, if you look at my Twitter feed, it literally looks like it's coming from Africa here. I mean, it's pretty dusty here. So a couple more quick questions. We got to take a break. Y'all talked about Pinatubo and the possibility of volcanic eruptions giving us a short period, 1, 2, 3, 4 years of cooling. What type of eruption would it take for us to see something like that, where you get a few years with global temperatures getting knocked back a little bit?
Oh, all you really need to do is repeat Pinatubo for that. That was, I believe, a 2-year or so impact in terms of cooler than normal global temperatures. But another thing you have to keep in mind, though, is where that volcano is located. So Pinatubo is located in the Philippines, and it's close to the equator. It has the potential to impact both hemispheres that way. But if you have a similar eruption, say in Alaska, it's going to have a big impact on the northern hemisphere, but it take a lot of time for that to spread, across the entire globe. And so it just depends really on where that volcano is located.
And that dust settles in the stratosphere. About what altitude does it typically stay?
So for your typical volcanic eruptions that penetrate into the stratosphere, it's, let's say, 12 to 15 kilometers typically. If you say the tropopause, the top of the troposphere is usually about 10 to 12 kilometers in the summer. So, 1 to 5 kilometers above the tropopause is pretty common. Something like Pinatubo, though, can go another 10 kilometers above that. And so the higher you put material in the stratosphere, the longer it takes to remove. And so you can imagine that if you just put a layer very near the boundary between the troposphere, where we have our weather, and the stratosphere, where things are pretty stagnant, there are processes that can, when you have big storms, that can pull that stratospheric air down and help clean that out. So the higher you put things into the stratosphere, the harder it is to remove.
Awesome. And one more question. A lot of young people listen to this show that are maybe in high school or college, and they're looking at careers. If somebody kind of is latched onto what you're talking about, they have a similar type passion, what advice would you give them if they had maybe an interest in winding up someday at NRL?
Well, I would say to follow whatever you're interested in and make sure you do internships. Take advantage of whatever opportunities are given to you. If you're interested in a research career, while you're an undergrad, see if you can get into a program that does a summer research job. We have an internship program here at NRL. It's called NREAP. And the students can spend an entire summer here working with a mentor. There are also options at universities. There are options like that at other government labs like NASA. I did one at NASA. So I would just make sure you take advantage of those types of opportunities while you're in school. And that'll help guide you then into other career paths. Like I had no idea I'd ever be doing work this detailed with satellite remote sensing. That just happened to fall in when I went into grad school. My original career path was going to be get a master's and then try to get into the weather service because I had a forecasting background. And then, things change and you just follow how they change.
Awesome. Well, listen, you've given us an hour of your time, David. You are so kind to do it. Thanks for fascinating topic. Love the.
I think he's going to stick around too, James. He wants to. He's a glutton.
I was going to say now, if you need to go, you take off. But if you want to hang in here, you are welcome to join us for the rest of the foolishness on this show. So,
I'll be here.
Good. Well, we're going to take a quick break here, and again, Brian Peters is out today, so there's no Professor Peters. He'll be back next week. But Tony Rice, our faithful astronomy correspondent, has a report, and we'll be right back with the weather roundup, picks of the week, and much more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
The global dust storm continues on Mars. Looking at temperature data from the Mars rover Curiosity since May, the insulating effect of all that dust in the atmosphere is evident. The spread between high and low temperatures has narrowed by about 36 degrees Fahrenheit, as dust blocks sunlight from reaching the ground and traps some of that heat in overnight. Daytime highs have dropped by about 28 degrees Fahrenheit, and overnight lows are warmer by about 18 degrees. Curiosity hasn't seen temperatures above freezing since late May. We've not heard from the Opportunity rover since early June. Elsewhere in the sky, Mars has been big and bright this July and will continue to be so through August, as it makes its closest approach to Earth later this month. At 7:45 UTC on July 31st, Mars will be at its closest since 2003 and won't be closer again until 2035. You can look for it about an hour after sunset in the east, and it reaches the highest point in the sky around 2:30 a.m. But ignore any social media posts or emails that you might receive claiming that Mars will look as large as the full moon to the naked eye. What's now become known as the Mars hoax first made the rounds back in 2003. And began as a misinterpretation and in true internet fashion took on a life of its own. So what's true and what's not? Mars will be at its closest and will be bright and easy to spot as a result, but it will not be as big as the moon. We measure the apparent size of things in the sky using angular diameter. The apparent diameter of the moon is about half a degree. The apparent diameter of Mars does not exceed 24 arc seconds. That's about half that of the moon. This is also not a once-in-a-lifetime event. It happens about every 2 years. You'll have your chance again in October of 2020. Now, Mars won't be as close, but I challenge you to see the 2 arc-second difference between 2020 and 2018, certainly with the naked eye. But what if Mars did appear as big as the moon? Well, Mars is about twice the size of the moon, but it's nearly 9 times the mass. If Mars ever did come close enough to rival the moon in the sky, gravity would alter Earth's orbit, and it would certainly create devastating tides. But it can't, so it won't, so we shouldn't worry about it, and just enjoy the night sky instead. That's your Astronomy Outlook. Follow me in RTP Hokie for more spacey stuff like this.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is foreseen. When colors blink by night or day, precipitation's on the way.
We're doing this show on July 16th, 2018. Time to do a little weather roundup. Let's go to Rick Smith in the vast deserts of Oklahoma. So heat is your big story, right?
Heat is the story, yeah. We've got, we are urging people to wear lightweight, loose-fitting clothing, to drink plenty of liquid. Oh, I know you love that. So
heat tips, yes, they're the greatest. Go into an air-conditioned room and get out of the sun.
Right, avoid the sun. Yeah, so we're doing all of that. It's the hottest temperatures this season. We haven't. I mean, Oklahoma City kind of had a. We're just going to be getting into that our first stretch of 100-degree days. And the problem is, a lot of times when we get into those 100-degree days, we're also getting into the dew points in the 50s. But we've got almost those Gulf Shores dew points, 75 and, mid-70s. So it's really just nasty. And they are getting a lot of heat-related illnesses. Ambulances are making a lot of calls. So it can be a serious situation. But, yeah, it's just hot.
And those things kind of build on themselves, almost like a feedback loop sometimes. The soil dries out and it just gets hotter and hotter. And
yeah.
At upper height, those are, I would say, a heat wave or a drought, least favorite kind of thing we're dealing with. How you doing on rain for the year out there, Rick?
A lot of the area was doing good. We picked up some good rain in June. We got some really good rains here in central Oklahoma. And we've been getting these spotty, thunderstorms every afternoon. But looks like that's going to shut down here later this week. But, yeah, the rainfall has been good. But, gosh, it's not going to take long to just suck all that moisture out, and we'll just, we'll be back. A lot of our areas teetering on drought a lot of the time anyway. So I think we'll get into it in a lot of cases.
Bill, it sounds like Rick's doing the weather, doing segment here from a urinal at the airport in Oklahoma City.
Yeah, I think he's got out his Commodore 64 and his 1200 baud modem. James, getting a little bit of interference there.
Yeah, we're starting to lose you there, Rick. The audio's fading fast, but we got most of that.
Faking us off, He's like, I gotta go. Got a bad connection.
Yeah, I've had enough of these guys. I can't hear you. I gotta go.
No.
So James Fan, do you remember what the high was in Birmingham and on this date in 1980?
Oh man, probably was 106, maybe
105. Yeah, 106 on the 13th. That was the hottest of that spell. And that was an 8-day streak of 100-degree temperatures that stayed unbroken. That record was unbroken until was it 2008 when we had the longer streak here?
Yeah, that 1980 heat wave though was just unbelievable. Didn't Wichita Falls hit like 119 during that thing?
Is that right, Rick? Can you comment on that?
I would have to check. I'm not sure.
Yeah, Rick wasn't alive. Rick was not alive in 1980, so he doesn't remember it.
Gosh, are you kidding?
I was on television here, and I remember the first couple of days I did the weather in a meat locker in a Piggly Wiggly, wearing a big Russian hat, and I was all bundled up, kind of, as a joke. And then it just got out of hand. I mean, we had a lot of elderly people that lived in some housing. These HUD housing facilities, and they started losing their life. They were afraid to open their windows. They didn't have air conditioning. They had these burglar bars, and they'd leave their doors shut, and they basically just died from heat. And it became serious. And that was by far, out of all my many years in doing this, the nastiest heat wave, nastiest summer ever. And much of the country dealt with it. How many people died, Bill? Do you know the numbers nationally? It was pretty bad.
Did my weather history story yesterday. We were already at 600 on the 15th, so I don't remember what the total overall was, but by that time we were already at 600, so I know it was well over 1,000. But the amazing thing about Wichita Falls, it was 114 on 2 different days, but it appears to me to be 41 straight days they were over 100, and that's unusual, obviously. Rick, I mean, how many standard deviations above the norm would that be?
A lot. I mean, that's just, that's just horrible.
I can't even imagine.
I can't imagine. I've gone through streaks that have felt that long living down in the Dallas-Fort Worth area, but No, that's just not right.
And in the month of August, obviously every day in the month of July was above 100, but there were only 5 days in the month of August that it was below 100. So that meant 26 days in the month of August on top of that. That's amazing.
I'm thinking we lost Rick again. So anyway, in terms of current weather, let's go to David. David, you're up in you're in DC, right?
No, I'm in Monterey, California.
Oh, wow. Okay. Well, goodness. Yeah. How's life out there in the West Coast?
It's good, but it's the opposite. We're in our summer chill right now. So July and August, we get a lot of low marine clouds over the coast. And so there are some days where we just hope to hit 70 on some of these days during the summer. But yet you can drive 50, 60 miles and it'll be 100.
We froze at a Giants game out there a few years ago in June.
Yeah.
My wife, I'm never coming to one of these again. I'm freezing out here. I mean, this is a pneumonia hole. And it was June, so I thought it was kind of refreshing. It was probably in the low to mid 50s or something. But
you should go in October when they're in the World Series, James. Then the weather's really nice in San Francisco.
Yeah, it's September, October is the time to be here if you want nice weather.
But I was thinking about DC weather. We got the All-Star game being played in Washington tomorrow night. The question is, will the Storms be out of there in time? What do you do if the All-Star game's rained out? Do you play it the next night, or I don't know what happens?
That's an interesting question.
The latest data I think it might be out of there in time, but we'll see. It might be an issue for the game up at where the Nationals play tomorrow night. But what else down here? We got an interesting trough digging down, a mid-latitude trough, which is very anomalous for summer. And that's going to bring down some pretty refreshing air for some of the northern states. Very refreshing for this time of the year, and maybe push lower dew points perhaps as far south as where we are down here. Tennessee, Arkansas, maybe parts of North Mississippi, North Alabama, and North Georgia later this week. So that'll be kind of interesting while the heat bubble is pushed out to the west. In the tropics, ain't nothing happening. I mean, nothing at all. So let's do picks of the week. Again, Aubrey is out, and I know that we have not had an email segment in a while, but we'll do a quadruple email segment whenever she gets back. But let's do picks of the week. This is where we go around the horn and share something weather-related, David. So we're warning you here. Let's go with Rick Smith. Rick, what you got for us? I saw that pick, and I like it. I like that paper, but tell us what you got.
Yeah, I hope my audio gets through here. The AMS this past week came out with a statement about safety for large venues, and our friend Dr. Kevin Claysall and Nate Johnson and others have been advocates for this for a long time, have been working on this. So that's my pick of the week. You can go, and it provides recommendations for anybody that operates a venue, whether it's a baseball stadium, a World Cup soccer venue. They had lightning there yesterday, I guess. Anywhere. So that's my pick of the week.
Awesome. And yeah, that is a very interesting statement. We had a big outdoor event here in this market last night. Really, I say last night. It was over the weekend. And man, the haters were out. Whoo, goodness. I
Why
don't
would they
know.
be out?
Oh, you go to any of their Instagram posts and just read the comments. It's brutal, just brutal. This is a large outdoor event called Sloss Fest, SLOSS.
Just standing out there getting the chance of getting struck by lightning? Is that what they were hoping
Well,
for?
I think there was some understanding, but for some reason there was a delay in getting everything back. And again, a lot of this might be out of their hands. I don't know anything about it. I mean, I don't know if anybody was providing weather support, but they did stop the event. And unfortunately, on Saturday and Sunday, they stopped it for hours because of nearly stationary storms with lightning output. And they got the show started really late last night on a Sunday night, and I think that's when one of the big headliners was playing. And unfortunately, on one of the 2 days, if not maybe both, it didn't rain that much down there, and the lightning was 5, 6, 7 miles away, but they didn't have any rain. And you know, in their defense, most people aren't weather weenies like we are. You know, they just, well, it's not raining. I don't see what's going on down here. They needed a better way of communicating what was going on. I think that was the biggest problem, was communication problem. And you can typically reach most all those people down there with Snapchat and Instagram. And they did the best they could do, but that's an interesting case study. But they did the right thing. Nobody was hurt down there. We had some pretty wicked lightning. And I would say, Bill, how many people down there? 40, 50,000 people at least.
Yeah, it's a huge event now.
Big crowd. But again, that goes back to Rick's pick, the AMS policy on outdoor events. And I think the AMS needed that. And if we have something going on, we can go back and just say, look, this is the professional society. This is what's said here. And it's a good statement. And Kevin and his team did a great job with that. And again, I hear it constantly. My daughter plays girls softball. We were down at some tournament and the umpire wouldn't stop it. There was lightning popping left and right within 2 or 3 miles. And the umpire said it wasn't raining. So he's not going to stop until it starts to rain, which is just idiotic. I mean, we've still got a lot of this going on. So again, maybe that'll help in some situations like that. My pick of the week, a little bit of research by UAH, the University of Alabama in Huntsville, titled, "Can Billions of Corn Plants Affect the Weather in Nebraska?" Very interesting little bit of research here. So again, the link will be up on the website, weatherbrains.com. Bill, what you got for us this week?
Yeah, I want to hear David's comment on that research in just a minute. Yeah, my late pick of the week, I was going to take the foghorn just because it's tradition, but I had to pick the NRL's tropical weather page because it is one of my favorites forever. And I've always loved that. So in honor of David tonight, I'm going to pick that. And James, I had to piggyback on what you were talking about with Sloss Fest. We had a thunderstorm last Thursday over the Crestwood neighborhood in Birmingham, and I got to go back and look at it. The composite reflectivity becomes really helpful, to me at least, in seeing where lightning might be about to develop. And you don't want to be that person who's on the receiving end of that first lightning strike because there's no thunder to warn you about that one. And this storm, by 4:32 was already, it really wasn't raining at the ground. But was extremely impressive already on composite reflectivity. And at 4:37, it produced lightning. And then the bottom fell out right after that. So, if you were around there at 4:30, you would have, seen some dark threatening clouds maybe. But, your first warning of the storm would have been that first lightning strike. And that first one can kill you just as dead as any of the other ones. Yep.
All right. Well, so let's go out to David. David, what you got for us? I know something really good. I sense this is going to be a good pick. Go.
All right. Well, first, just to comment on the whole corn thing.
Yeah. There you
So
go.
I lived in Nebraska for almost 5 years, and there was a lot of talk about the potential impact of moisture released from the corn and how that impacts the weather. You do end up with really high dew points in the late summer when that corn reaches its mature stage. It gets really sticky. Sometimes just as bad, if not worse, than Miami. And I think it's people in Iowa actually call that corn sweat season. So anyway, but as far as my pick of the week goes, it's actually a figure in the paper that we have on this case I mentioned from the 2017 Piracy B event. It shows the smoke in the stratosphere. Actually, it's a satellite image showing the smoke actually above the clouds, extending from the Canadian Arctic over the Atlantic Ocean on its way to Europe. It's really impressive, and really any image of that event is worth noting. And we also have a website available along with that tropical page. There's a satellite website with our piracy B detection capability included. So we've actually developed an algorithm that's specifically focused at those thunderstorms. It's still very much in development, but because they're different, the clouds are microphysically unique, there are ways you can tease out those clouds relative to other convection. So there's a lot of cool stuff there.
Awesome. And a big favor, if you can, Brian Peters, who normally handles the show notes, he is napping through this tonight. So if you could get those URLs and send them over to our regular email address, email@weatherbrains.com. That way the JP, who's doing the audio production, and he'll be doing the show notes. That way he can get those in the show notes. because we kind of like to have all those links gathered together nicely, because people typically listen to this and they can't remember this while they're driving down the road, and that way they can refer back to it later. So that's awesome. So Bill, let's go real quick before we get out of here. I want to go back to the National Weather Association. Let's kind of plug the event, the annual meeting, because it is coming up pretty soon. And I think you say early registration ends today.
I think it ends tonight. I may be wrong about that, but I'm going to go as soon as the show is over here and make sure that I'm registered. But fortunately, I already have my hotel room. And I'll be going up on Thursday and staying to the following Thursday. It's a huge event. It kicks off on Saturday, August 25th with the Weather Ready Fest at the St. Louis Science Center. Huge event, expecting 7,000 people to attend that day. We'll have over 50 exhibitors, 9 great speakers, 3 stage shows, 3 great children's educational workshops. It's just going to be an amazing event in an amazing venue. And it's free to the public. You do have to pay to park unless you park on the Forest Park side near the planetarium. But you'll come and have a great time with a lot of practitioners in St. Louis and nationally talking about weather and disaster relief and mitigation. And then, of course, James, we kick off on Saturday with the broadcasters and the students. And then we get into 4 days of additional just incredible talks about the weather. I mean, it is my favorite week in weather. Because you learn so much, not to mention all the incredible networking that goes on and all the special fun events that occur with it too. But just to sit for 7.5, 8 hours a day in a conference room, listening to some of the brightest and best operational meteorologists around the country and some from around the world sharing their knowledge is just a phenomenal opportunity.
Yeah, and I've said this before, and as old as I am, I've been to most all of these conferences and events, and to me, the NWA, it's kind of like a family reunion because, and again, maybe it's just a bunch of operational guys, but when I go to this thing, it's people I know, they're my people, we have the same concerns, we have the same issues we're facing, and I don't know, it's just great. And again, the AMS is cool. It's just AMS is overwhelming. If you've been to one of those in January, I mean, you've got to map that thing out, and you've got to literally work on, what you're going to go listen to well in advance. With the NWA, you just kind of come, and it's not as overwhelming. And this will be. I've not been able to get to one here in a few years, so this is my first one in a while.
You were at Madison?
Madison, Wisconsin. That was like in 2013 or something.
2012. And James will be doing the WeatherBrains from the Research Operations Nexus, the RON event that's become so huge on Monday night following the icebreaker. So I'm really excited about that.
So let me ask David a quick. David, do you ever snoop down to our level and rub elbows with operational guys, or do you just stay to yourself at those AMS meetings?
Oh yeah, I love rubbing elbows with. Like I said, I was originally wanting to go the operational route. I've never been to the NWA meeting itself, but I've been to AMS for most of the last 8 or so years. And you talk about that being big, but because of the satellite work we do, we go to the AGU meeting, the American Geophysical Union, and that's even bigger. So you want to talk about mapping out your plans. That one has almost 20,000 attendees.
Oh,
they're not all weather related, but it's a big meeting.
Wow. Well, we got to get you to one of these NWA meetings. I think you'd have a good time if it's deep down in your heart. If you like forecasting, once a forecaster, always a forecaster. I think you'd like it.
That's very true. I probably would, yeah.
Not too late to sign up for St. Louis. Just too late maybe to get in the conference hotel.
You got to, about to say, you'll be staying in my hotel, the Roach Motel down the street, since they have no more rooms left. But you say there are some alternatives, and Bill nearby.
There are great alternatives in downtown St. Louis. They're really close to
people sign up and they see that the big place is full. Don't panic. I mean, there's going to be a bunch of us staying at the alternative sites. And again, the other thing, the cost can be overwhelming if you see what it costs to go to the whole thing, where many times employers and the Weather Service and NOAA will offset that. But for people that just want to go for a day, don't you have like day rates where you just go for 1 or 2 days and it's a reduced registration fee?
Yes, you can, and just being an NWA member knocks off enough of the price to cover your membership for the entire year. So it is still one of the best bargains in weather, because you can't put a price on all the networking and learning that you get.
Right. And again, we talked about younger people. If you are a college student,
oh yeah,
I really advise you to come to one of these, because the connections that you can make, and I'm speaking, I think, for most of us. I mean, we're very approachable people. You come to me at one of these things, I'll be glad to talk with you and to listen to you and where you want to go and what you want to do. And if I know people that can help, I'll be glad to set you up with them. And I do whatever I can to help young people. And I think there's just the other good thing about this bill, there's not that many jerks at this thing, I mean,
no, they're none. They're not allowed. So I've never run into a jerk.
The jerks have been weeded out at the door.
We have security for that sort of thing.
Yeah, about to say, which means they'll probably kick me out when I show up at the front door at this thing. But anyway, I think you will enjoy it. No, I went to one of these. I went to the one in Norman, Rick Smith's.
Oh, that's right. Yeah, we did.
They had one in Oklahoma City, not Norman, but Oklahoma City. When was this, Rick? About 3 years ago?
2015, I think.
Yep, 2015. That's right.
Yeah.
Okay, so I did Madison and I did Oklahoma City. So it's about time. So we'll have a good time with that.
Yeah, there's James, on the students especially. There's a special mentoring session on Sunday that just is getting bigger and bigger and bigger and bigger. And if you're a student, make sure you sign up for that. Of course, full-time students, the early bird registration is only $179. After it says by July 20th, so I guess we've got the rest of this week. I for some reason had told myself that it was tonight, but early bird rates are extended through July 20th. For a full member, it is only $449, but for us, that's the regular. The early bird is $359. For a student, though, it's only $179, so it's definitely worth that.
Okay, I got to go. I'm the lead. We've had flooding, so let's see. Just one more question here, David. Last song that you played on your phone or listened to in your ear.
Oh, cool.
Oh, let's see. That was what was that? I think it was.
I'm trying to figure out what an aerosol guy listens to. I mean, have you ever heard the song?
I'm all over the place, but I think the last song it was a Journey song. I think it was.
Oh, there we go.
I think it was
like
Wheel in the Sky.
Now we're talking.
Yeah.
You ever heard the song "Smoke from a Distant Fire"?
Ooh, Sanford Townsend Band.
I've not, but I've heard "Smoke on the Water."
Oh, there you go. See, I'm just thinking of the Smoke Aerosol song. My favorite, "Smoke in the Water" by Deep Purple was great, but "Smoke from a Distant Fire" was the Sanford Townsend Band from 1977, I want to say.
That sounds good.
But listen, hey, we got to wrap this thing up. Guys, we had a great show. Thank you so much for joining us. If you want to get in touch with us, the email address, it is email@weatherbrains.com. And we're going to have the show notes and everything else up on the website as well. And even if Brian's not here, JP's going to take care of that. What else, Bill? What are we missing here?
That's it. We got 2 shows next week.
Yeah, and David, if they want to get in touch with you, what's a good way to do that? Somebody wants to email you or get in touch with you on social media.
Well, you can use my Twitter. It's Dr. Dave Peterson. That's the name, with capitals of each word. And I can provide an email address, too, if needed.
Okay, awesome. Well, listen, thank you guys for listening and watching. Y'all have a marvelous week on behalf of the entire WeatherBrains crew. I'm James Spann. Thanks for listening. Do have a great week, and God bless. Thanks, everybody.
Thanks, everybody.
All right,
great, David. Rick, thanks for hanging in there.
No problem.
Yeah,
thank y'all.
Bye-bye.
Thanks for having me.